ax square plus bx plus c is equal to 0 be our quadratic equation. And the discriminant d is equal to b square minus 4ac. Right. Now, the nature of the roots completely depend on d. The nature of roots completely depends on d. Okay. Here where a, b, c belongs to R, real number. For d equal to 0, d greater than 0, and the case d less than 0. If d is equal to 0, roots are equal and real. Since x is equal to minus b plus or minus root d by 2a is the value of x. Okay, then on the number line we can mark the roots. The roots are real and equal. So 2 roots. So 2 roots are coincident. 2 roots. Okay. Now consider the case d greater than 0. Then roots are real and different. We can mark the roots on the number line. The roots are real and different. These are the roots. Now d less than 0, the roots are imaginary. Or complex roots. If one root is a plus ib, then other root is equal to a minus ib. They are in conjugate pair. Okay. For d less than 0, then our quadratic equation is ax square plus bx plus c is equal to 0. If that is x is equal to minus b plus or minus root d by 2a. Okay. If b greater than 0 and d less than 0, this implies the roots are lying in the LHS of the complex plane. This is our complex plane, real axis and imaginary axis. Right, imaginary axis. That means if b is greater than 0 and d less than 0, roots lie on the LHS, left hand side of complex plane, and they occur in complex conjugate. If b less than 0, and d less than 0, then roots lies on RHS of the complex plane. This is the RH, right hand side of complex plane. Right hand side of the complex. The roots will lie in this side. Here, LHS in this, and they are complex conjugate also. This is our roots. This is our roots. Right. Now, b is equal to 0 and d less than 0. Our equation become ax square plus c is equal to 0, or x square is equal to minus c by a equal to plus or minus root of minus c by a minus plus or minus iota root c by a. So roots are purely imaginary. Roots are purely imaginary and lies on imaginary axis. Lies on imaginary axis. In this case, roots lies on the imaginary axis. These are the roots. Real axis and imaginary axis. Now, A, B, C are rational numbers. That is A, comma B, A, B, C belongs to Q. Okay. What is the rational number? That is Q is equal to P by Q form. P is integer and P and Q are integers. This is the rational numbers. If ABC belongs to Q, then the nature of the roots entirely depending on D. Now case D equal to 0, D not equal to 0. If D equal to 0, roots are D equal to 0, roots are real and equal and perfect square. Quadratic equation is a perfect square. That means x is equal to minus b plus or minus root d by 2a. If d is equal to 0, implies x is equal to minus b by 2a and minus b by 2a. So these are the roots. So our equation become x minus b by 2a into x minus b by 2a. That is x plus b by 2a the whole square is equal to 0 is our quadratic equation. Okay. For example, x square plus 2x plus 1 is equal to c. Plus here a is equal to 1, b is equal to 2 and c is equal to 1. And d is equal to b square minus 4ac. That is equal to 2 square minus 4 into 1 into 1. That is equal to 4 minus 4 is equal to 0. Our roots are x is equal to minus b. What is minus b? Minus 2 plus or minus root 0 by 2 into 1. That is x is equal to minus 2 by 2 is equal to minus 1. So x minus minus 1 into x minus minus 1 is equal to 0. Or x plus 1 the whole square is equal to 0. This is a perfect square. D not equal to 0. This implies roots are different. That means roots are distinct roots. In this case, first case, D greater than 0 and D less than 0. D greater than 0. This is again two cases. D greater than 0 and not equal to a perfect square. And the case D is equal to a perfect square. Okay. For example, here D is equal to 20. That is not a perfect square. Here D is equal to 25. That is a perfect square. Then roots are irrational. Here this is a perfect square. That implies roots are rational. That is, roots appears in P by Q form. P and Q are integers. If one root is P plus root Q, then other root is P minus root Q. They appears in conjugate pairs. Okay, that is one. If this is root 20, we can write x is equal to minus b plus or minus root 20 by 2a. That is equal to minus b plus or minus 2 root 5 by 2a. This is appear in the form like this. If one root is 1 plus root 3, then other root is equal to 1 minus root 3. If it is a perfect square, then if D is equal to 25, then x is equal to minus b plus or minus root 25 by 2a. That is equal to minus b plus or minus 5 by 2a. This implies this ratio is a rational ratio. If D is less than 0, roots are complex roots. If one root is P plus IQ, other root is P minus IQ. They appears in conjugate pair. A equal to 1. And B and C belongs to integer, and B and C are integers. And D is equal to a perfect square. Then roots are integers. if roots are rational, then D is equal to perfect square. Then note, if roots are irrational, then D not equal to a perfect square. If roots are equal, then D is equal to 0. If roots are distinct, then D greater than 0. If roots are imaginary, then D less than 0, and roots occur in conjugate pair. Let's consider ax square plus bx plus c is equal to 0. If one root is alpha, if one root of this equation, is 1, then a plus b plus c is equal to 0, and other root is equal to c by a. Okay, let alpha and beta be roots. Alpha is equal to 1 implies f of 1 is equal to 0. That is a into 1 square plus b into 1 plus c is equal to 0, or a plus b plus c is equal to 0. Now the product of the roots is equal to alpha beta is equal to c by a. Here alpha is equal to 1. That is 1 into beta is equal to c by a, implies beta is equal to c by a. So the other root is c by a. If a minus b plus c is equal to 0, then one root of the quadratic equation is minus 1, and other root is equal to minus c by a. Okay. Consider, let ax square plus bx plus c is equal to 0. Let alpha beta be the roots. If one root is equal to 1 minus 1 means alpha is equal to minus 1. That implies, and alpha into beta is equal to C by A. This implies alpha is equal to minus 1. Minus 1 into beta is equal to C by A, or beta is equal to minus C by A. And this f of minus 1 is equal to 0. This implies A into minus 1 square plus B into minus 1 plus C is equal to 0. That is A minus B plus C is equal to 0. If one root is minus 1. Let A minus B into x square plus B minus C into x plus C minus A is equal to 0. Find roots. Find roots. Here the coefficients are cyclic. Let this expression is equal to ax square plus bx plus c is equal to 0. Here a is equal to a minus b. B is equal to b minus c, and c is equal to small c minus small a. Right. Now, what is f of 1? F of 1 is equal to a minus b into 1 square plus b minus c into 1 plus c minus a is equal to 0. That is equal to a minus b plus b minus c plus c minus a. C minus a. C minus a. A and a which cancel, b and b cancel. This is equal to 0. Therefore, x is equal to 1 is a root. 1 is a root. Then other root of this equation is 1 into beta is equal to c by a. Here c is equal to small c minus a, and a is equal to a minus b. So roots are x is equal to 1 and x is equal to c minus a by a minus b. Alpha and beta are the roots of the quadratic equation ax square plus bx plus c is equal to 0. Then we can write x minus alpha into x minus beta is equal to 0. But if f of x is equal to ax square plus bx plus c is a polynomial function, that means not equal to 0, and alpha and beta be the roots of this polynomial function, and alpha and beta be the roots of polynomial function. Then we can write f of x is equal to a into x square plus b by a x plus c by a. That is equal to a into x square minus b by a is equal to minus b by a is the sum of roots. So this is equal to minus alpha plus beta into x plus alpha beta. This is equal to a into x minus alpha into x minus beta. Roots are also called as zeros of polynomial. So this is another name for roots. So that is zeros of the polynomial. If for the polynomial, for the quadratic equation, ax square plus bx plus c is equal to 0, and 4a plus 2b plus c is equal to 0. Find roots. X is equal to 2. This equation becomes a into 2 square plus b into 2 plus c. That is 4a plus 2b plus c. This is given as 0. Therefore, x is equal to 2 is one root. And to find other root, the product of the root, alpha into beta is equal to c by a. One root is 2. That is alpha is equal to 2. 2 into beta is equal to c by a, or beta is equal to c by 2a. Therefore, roots are x is equal to 2 and x is equal to c by 2a. A polynomial f of x has two roots, 1 plus root 5 and 1 minus root 5, and satisfies f of 1 is equal to 2. Find the quadratic polynomial. Let the quadratic polynomial f of x is equal to ax square plus bx plus c. We can write this is equal to a into x minus alpha into x minus beta. Okay, that is equal to a into x minus, one root is x plus 1 plus root 5. 1 plus root 5 into x minus 1 minus root 5. This is a into x minus 1 minus root 5 into x minus 1 plus root 5. So a into x minus 1 whole square minus 5. That is equal to a into x square minus 2x plus 1 minus 5, or a into x square minus 2x minus 4. Now, condition given, f of 1 is equal to 2. F of 1 is equal to 2. That implies a into 1 square minus 2 into 1 minus 4 is equal to 2. So a into 1 minus 2 minus 4 is equal to 2. A into 1 minus 2 minus 4. Minus 5 is equal to 2, or a is equal to 2 by minus 5. polynomial f of x is equal to minus 2 by 5 into x square minus 2x minus 4.